Alrighty, so as Harry just said, heat energy is all about the movement of atoms, the vibration and the movement of atoms. We know that the hotter an object gets, the more movement we see in our atoms. Can we see that? No. But we know that's occurring. So what's temperature then? How hot it is. Nathan?
Temperature is how much the atoms are moving.
Very good. So wouldn't that be the same as heat?
Yes. But
I
it
don't
sounded better.
Temperature's a measurement.
Nick?
To measure how hot or cold something is, it describes the average kinetic energy within the...
Oh,
He searched it up.
No, we've done this in chemistry.
Yeah, we did. Yeah, we also learned about this in chemistry, but I don't remember what we wrote down.
you know it's a good definition when they're calling you for plagiarism. That's good. Okay. The average kinetic energy, I don't want of an atom, I want of atoms in an object. Oh, and I haven't given you anything to work with. That's good from me. That was a really well, that's why you should proofread your exam questions. Contrast heat and temperature using the following to support your response. And the following would be a 50 degrees Celsius, 400 litre bathtub. It's a big bathtub, it's a dream, that one. And a 100 degrees Celsius, 250 ml cup of coffee or water. Doesn't matter. How?
So which one has more of the other?
Well, I said before that I don't think that temperature and heat are the same. And we know what's a measure of heat. What's their unit for heat? And we're describing the heat. What do we use? Oh, sorry, temperature, not heat.
Degrees.
Degrees Celsius. There's a couple of units, but the one that we use in the functioning parts of the world is degrees Celsius. Okay. Now, degrees Celsius is a measure of temperature. We can see straight up which one of those has a higher temperature.
The 100 degrees.
Very good.
Celsius, 250 milliliter coffee cup.
Very
No,
good.
okay, no,
Cup coffee.
Cup coffee.
Yep, you get the idea. We don't use ovs in physics. You figure it out. So, the cup of coffee clearly has the higher temperature, but does it have the higher heat? So everyone in the room says no, but then when I asked you 30 seconds ago why they're different, it was very hard to verbalise. So why do we think the bathtub has more heat energy?
Because it's releasing more particles than the cup is.
Yeah?
Surface area.
Oh, it's because it has more atoms moving around.
Very good. More mass. Yep.
Oh, it's more distance.
Yeah, mass.
I think it's more related to the mass and the distance, but the distance will play a factor.
Area. Sounds better than distance.
Mass. It's all about mass. Okay? There are more particles in here, so the total kinetic energy of the bathtub is greater than the total kinetic energy of the cup, but the average kinetic energy inside the cup is greater. And the way I like to think of it is if I was to put something, an ice cube's not going to work, but if you were to put a whole bunch of objects that were really cold, which one would heat the really cold object up? So if you were to throw the cup of water on a lake, on a frozen lake, would you get much ice melting?
No.
What about that 400 litres? You throw that on top, do you reckon you're going to get a lot of ice melting? Okay, so it's clearly got more thermal energy. Happy with that? So your response should be heat energy accounts for the amount of the substance. Temperature is only concerned with the average. I'm just going to put KE. You know what that means?